says rationalise the denominator. The denominator is the bottom of the fraction, and rationalise means make sure that it's a rational number. Surds are irrational numbers. They can't be written as fractions, and if you write them as a decimal, they'll go on forever without any pattern. So if a question says rationalise the denominator, we need to make sure there's no surd on the bottom of the fraction. This question says 6 over root 2. I want to get rid of the surd from the bottom of the fraction, and I can do that by multiplying the top and bottom of the fraction by the same thing. So if I had a fraction, say I had 1/2, and I multiply top and bottom by the same thing, if I multiply by 2, I'll get 2/4, and that's the same as a half. If I multiply by 5, I'll get 5/10, and that's still the same as a half. So when I've got a fraction, I can multiply the top and the bottom by the same thing, and the fraction stays the same. It stays equivalent. So with 6 over root 2, I can multiply top and bottom by root 2. Because I know if I do root 2 times root 2, I'm going to get a rational number, which will be 2. So let's do this multiplication. 6 times root 2 is 6 root 2. And root 2 times root 2 is 2. So we have rationalised the denominator. The denominator is now a rational number. But I can simplify this further. If I've got 6 root 2's and I divide it by 2, I've got 3 root 2's. So there's a simplified answer. Okay, a question for you to try. So pause the video, give it a go, and press play when you're ready for the answer. So we've got 12 over root 3. This time I'm going to multiply top and bottom by root 3, because that would give me a rational number on the denominator. So 12 times root 3 on top is 12 root 3, and root 3 times root 3 on the bottom is just 3. So I've rationalised the denominator. I can also simplify this further. So 12 root 3 divided by 3, 12 root 3's divided by 3, that's 4 root 3's. Okay, here we've got a different question. This one says 6 over 2 plus root 5. So we still want to rationalise the denominator. We still want to get rid of the surd from the bottom. But this is more complicated because we've got 2 plus root 5 on the bottom. So we're still going to multiply top and bottom of the fraction by the same thing. But what can we multiply by that would get rid of the surd from the denominator? What we're going to use here is the difference of 2 squares. So if you remember when we have something like x plus 2 times by x minus 2, when we expand double brackets with 1 plus and 1 minus, so we'll do x times x, we'll do x times them both and then 2 times them both. X times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x, and 2 times negative 2 is negative 4. And when we collect the like terms, the middle terms, the negative 2x plus 2x, they cancel out, so they disappear. So in this example, it's just x squared minus 4. And this is what we're going to use to get rid of the surd from the bottom. So where we've got 2 plus root 5, we're going to multiply by 2 minus root 5. And whatever we multiply the bottom by, we have to multiply the top by as well. So if we multiply top and bottom by 2 minus root 5, we're going to get rid of the surd from the denominator. So let's do these multiplications. So we've got 6, expanding the bracket, so 6 times 2, and then 6 times negative root 5. 6 times 2 is 12. 6 times negative root 5, so a positive times a negative is a negative, and 6 root 5s are 6 root 5. And then the denominator, so 2 times both the terms in the second bracket, and then root 5 times both the terms in the second bracket. 2 times 2 is 4. A positive times a negative is a negative. 2 root 5s is just 2 root 5. And then root 5 times them both, so root 5 times 2, which is 2 root 5. And then root 5, positive times a negative, positive root 5 times negative root 5, it's going to be a negative, and root 5 times root 5 is 5. So when we simplify the bottom, when we collect the like terms, we've got minus 2 root 5 plus 2 root 5, which is nothing. They cancel out. So we've got 12 minus 6 root 5 on the top, and we've got 4 minus 5 on the bottom, which is minus 1. So we have rationalized the denominator. We can simplify this, so we can divide the terms on the top, divide them both by negative 1. So when we divide by negative 1, that's the same as timesing by negative 1. It just changes the signs. So 12 divided by negative 1 is negative 12, and negative 6 root 5 divided by negative 1, a negative divided by a negative is a positive. So plus 6 root 5. And that is the answer. Okay, a question for you to try. So pause the video, give this one a go, and press play when you're ready for the answers. Okay, so I've got 3 over root 2 minus 1. I want to get rid of the surd from the bottom, so I'm going to multiply by root 2 plus 1 this time. And whatever I multiply the bottom by, I also multiply the top by. So if we do the expansions, on the top, the numerator, root 3 times root 2 is 3 root 2. And 3 times 1 is 3. And the bottom, root 2 times root 2 is 2. Root 2 times 1 is just root 2. Negative 1 times root 2 is minus root 2. And negative 1 times a positive 1 is a negative 1. So collecting the like terms, so positive root 2 take away root 2, that's going to cancel out. And I've got 2 take away 1, which is just 1. So I've got 3 root 2 plus 3 over 1, which is just 3 root 2 plus 3. One more example here. So it's a very similar question to the last one, just with a more complicated numerator. So here we've got 2 plus 4 root 3 over 5 minus root 3. So the process to rationalize the denominator is the same as the last question. So the denominator is 5 minus root 3. So we're going to multiply top and bottom by 5 plus root 3. So we can have double brackets on the top and the bottom to expand. So let's just do the expansion. So on the top, I've got 2 times 5, which is 10. 2 times root 3, which is 2 root 3. Then I've got 4 root 3 times 5. 4 5s are 20, so 4 root 3 times 5 is 20 root 3. And I've got 4 root 3 times root 3. 4 times root 3 times root 3. Root 3 times root 3 is 3, so it's 4 times 3, and that's 12. On the bottom, I've got 5 times 5, which is 25. I've got 5 times root 3, which is 5 root 3. Negative root 3 times 5, so minus 5 root 3. And negative root 3 times a positive root 3, so that's negative 3. So collecting the like terms, so on top I've got 10 plus 12, which is 22. And I've got 2 root 3s plus 20 root 3s, so that's 22 root 3s. On the bottom, I've got 25 take away 3, which is 22. And I've got 5 root 3 take away 5 root 3, which is nothing. So that cancels out. So I've got 22 plus 22 root 3 over 22. So I can simplify this one by dividing both the terms on top by 22. And that's going to give me, well, 22 over 22 is 1. And 22 root 3 over 22 is 1 root 3, or just root 3. Question for you to try, so pause the video and give it a go. Okay, so 1 plus 3 root 2 over 6 plus root 2. So we've got 6 plus root 2 on the bottom. So to rationalise the denominator, we're going to multiply by 6 minus root 2. And whatever we multiply the bottom by, we're going to multiply the top by the same thing. So let's do the expansions now. 1 times 6 is 6. 1 times negative root 2 is going to be negative, and 1 root 2 is just root 2. 3 root 2 times 6, 3 times 6 is 18, so that gives me 18 root 2s. And positive times a negative, so negative 3 root 2 times root 2. Root 2 times root 2 is 2, so I've got 3 times 2, which is 6. And on the bottom, 6 times 6 is 36. Positive times a negative is negative. 6 times root 2 is 6 root 2. Root 2 times 6 is 6 root 2. And positive times a negative is negative. Root 2 times root 2 is 2. So collecting the like terms, so on top, I've got 6 take away 6, which is nothing. And I've got 18 root 2s, take away 1 root 2, which is 17 root 2s. On the bottom, I've got 36, take away 2, which is 34. And my negative 6 root 2 plus 6 root 2 cancel out, and that's nothing. So I can simplify this. I can divide top and bottom by 17, which will give me root 2 over 2. And I just want to show you that you can check answers on the calculator if you've got a calculator. So if I type in 1 plus 3 root 2, over 6 plus root 2. I get my answer of root 2 over 2. So the calculator will simplify surds for you, and it will automatically rationalize a denominator. But if you're being asked this question, you probably won't have a calculator. Okay, so to finish up, 3 questions. Pause the video, give them a go, and press play when you're ready for the answers. Okay, question 1. So 10 over root 5. We're going to multiply top and bottom by root 5. So the top now, we've got 10 times root 5, which is 10 root 5. And the bottom, root 5 times root 5 is 5. So 10 root 5 over 5. And I'm going to simplify by dividing the top by 5. And that's going to give me 2 root 5s. Question 2. 4 over 3 plus root 5. So to rationalise the denominator this time, I'm going to multiply by 3 minus root 5. Multiply the top and the bottom by 3 minus root 5. So for the top, 4 times 3 is 12. 4 times minus root 5 is minus 4 root 5. On the bottom, 3 3s are 9. 3 times minus root 5 is minus 3 root 5. 3 root 5s is 3 root 5. And positive times a negative, root 5 times root 5 is 5. So the top line can't be simplified. The bottom line, the middle bits cancel. That's why we did it. And we've got 9 minus 5, which is 4. So I can simplify, divide both my terms by 4. Both my terms are numerator by 4. So 12 over 4 is 3. And 4 root 5 over 4 is just root 5. And the last question, 1 plus 3 root 2 over 2 minus root 2. So to rationalise the denominator, we're going to multiply the top and bottom by 2 plus root 2. So expanding the top, 1 times 2 is 2. 1 times root 2 is root 2. 3 root 2 times 2 is 6 root 2. And 3 root 2 times root 2, so 3 times root 2 times root 2. Root 2 times root 2 is 2, and 3 times 2 is 6. And the bottom, we've got 2 times 2 is 4. 2 times root 2 is 2 root 2. 2 times negative root 2 is minus 2 root 2. And we've got a negative times a positive. Root 2 times root 2 is 2. So collecting the like terms, on the top we have 2 plus 6, which is 8. And we've got root 2 plus 6 root 2s, so 1 plus 6, 7 root 2s. On the bottom, our middle bit cancels out, so we've got 4 minus 2, which is 2. And that's as simple as it can get. So we can't divide both the top terms by 2, so we're going to leave it as 8 plus 7 root 2 over 2.